Okay, so hello everyone. We are group 78. I'm Jiajun Li.
I'm Yi Zhang.
And firstly, I will give a very brief introduction to our project. So our project background is that after graduation, most students are going to work and start their professional development. Income is always an important part that everyone cares about. To have a deep understanding of income data, we decided to do some research on how the aspects of people are related to their salary. So for example, search for instance with a salary between a salary range. Search for instance with salary larger than 50,000, calculating the average salary and calculating the percentage of a specific type of workers whose salaries are larger than 50,000.
For the data site, we selected data sites are about income. Each data site included the following attribute: age, income, education, occupation, marital status, race, and sex.
Okay, so now I will firstly introduce our design and the implementation for text one. So for my part, I implemented the makedir, ls, and cat function. So I will let's first see how makedir function works. So right now, if I use ls, we can see our current directory have no directories in the current directory. So now I will create a directory called my files. Now we can see we have a directory called my files. And if I create another one, say data, and we can see we have two directories, which are data and my files. So here, let's look at how I implemented those functions. So for the makedir function, there is a JSON file of users directory data stored on Firebase. And when the user creates a directory, we store the information of the user and directory into the JSON object on Firebase. So here you can see our code. So there are several cases we check if the user inputs valid if user has a valid input. And so for the ls function, we simply get the required data from Firebase and then show the information of a given directory. And the last function I implemented for task one is cat. So let's first put those two data sets into our Firebase. Just wait a second. Okay, so after we upload to dataset, if I use cat on this salary dataset, it will fetch data from Firebase. So here we can see this salary dataset. And if I cat this income dataset, and we can see the EDFS successfully fetch this income dataset. And it just look like this. So back to our implementation. For the cat function is quite simple. So it just find the location of the files, which includes an URL for the data. And we just get the data stored in the URL and show the data using pandas data frame.
I'm going to show you the put function. Put function will allow users to upload a file to the file system. Also, the user can choose the directory, the number of the partitions. For example, you can see this case in the Jupyter notebook. We have a file and a path, which is a directory in our system. And 3 is the number of the partitions. If I run this function, it's going to put a salary data site into Firebase with 3 pieces. And also this is another example. you can see here. And the next one is a get partition. This will show the location of the partition of the field. If I run this, let me check. We want to know the partition locations, the locations of the partitions of the salary data size. So if I run this command, and you will have three locations, because we cut the data into three pieces. And the next is get partitions. This method will return the location of partition of the file. This method will return the content of the partition number of the specified file. For example, if I run this, it will try to get the first part of the salary data set. Remember, we have three parts of salary data set, which are stored separately. You can read this data. This is not the whole data of salary data set. It's just the first part of it. It's long. And the last one is remove functionality. Remove functionality is just delete the JSON object in Firebase totally, which include the partition location and the real data. Yeah, that's the first part. That's our first part.
Okay, so for text 2, we implemented the partition-based and reduced on data stored on EDFS. So for each search or analytics function, the function will first call the map partition function to search or analyze data for each partition according to the requirements. Then the reduce function will process the result of each partition and collect them together to form the final result of the search or analytics function. And the implementation is shown in this code. And I will first, so for task 2, my part is implementing the map partition. And so I will first introduce how we implement the map partition function. So as you can see, the map partition takes three parameters. The first one is one partition P, and the second one is a search or analytics function. And the third one is the required arguments for the function. So this map partition will call respective search or analytics functions and finally output the result of one partition. And the respective search and analytics functions are shown below in this picture. So we can see we have two search function and two analytics function. And basically for each of those functions, we can see it will have two parameters, which is P, which is the one partition, and args, which are the arguments. So for the first function, which is get job with salary, it do very simple jobs, which is filtering salaries with lower bound and upper bound. And the second function, which is much more simpler, which is filtering the income 50K, these attributes, it will find out whose value is equal to 1. And the third function is basically finding a specific job title. For example, if the argument says iOS developer, this function will return the data frame with all iOS developer, and the fourth function will return the will find out the person whose occupation is equal to the argument, say if they are sales person or other types, and it will return the total length of those how many number of those person and how many number of those person whose income is larger than 50K. Okay, so that's all my part, and let my teammate to introduce the reduce function.
Okay, for the PMR, it has two parts, mark partition and reduce. The reduce function will take the one partition and a search or analytics function as inputs. It will call a respected reduce function to collect the results of different partition and form a final result. As you can see, this part, we have two analytics function and two search functions. So we also have 4 reduce function in total. The following pictures is about our reduce function. For example, reduce average salary function will collect the result of each partition, and finally find the result of average salary.
So for task 3, first we use Jupyter Notebook as our app. So as you can see, we implemented EDFS simulator as a class. So basically, after you creating an instance of EDFS simulator, users can use the functions it supports, such as mixer, ls, remove, and so on. So another part I did is the CD function. So basically, it allows user to interactively navigate through the EDFS. And let me show you how this works. So let's see. The current directory is the root directory, which has 3 directories, which are data, my files, and user. If I go to the user directory, and we can see there is a Jack child directory and a Mark child directory. If I go into the Jack directory, we can see this user has a data set called salary data set. So if we go back, we can see we go back to this directory and we keep going back. We will go to the root directory, which contains 3 directories. So this is how we implemented the CD functions, and it's quite simple. So one requirement is that users are required to only navigate to a direct child or parent directory. So for example, users are not allowed to navigate to users/Jack. Instead, they need to navigate to users and then navigate to Jack. Okay, so the last part, we will talk about our search and analytics functions. So I was responsible for 2 search functions. The first one is this one, get job with salary for the salary data set. So this function is basically find jobs using a lower and upper bound of salary. And we can use this function to find what kind of jobs are in different salary intervals. So let me show you how this works. So right now I set the lower boundary to 200,000 and the upper boundary to 300,000. If I run these functions, it will give me the result for each partitions. So we can see, so for the first partition, there are 260 jobs whose salary is less in this interval. And for the second partition, there are 240, and in total there are 742. So if we change the boundary a little bit, say we change the lower bound to 270 and run this function again, we can see the total jobs reduced to 144, which makes sense since there are the fewer jobs lies in this interval. So for the second search function, which is get people larger than 50K for the income data set, this function basically find people with subsidied attributes whose salary is larger than 50K. And we can use this function to see what attributes of a person might affect people's salary. So first, let's see, let's say we just use edge, and we run this function, and it will give me result for each partitions. So all those results are people whose salary is larger than 50K. So by briefly looking through those results, we can see most of people whose salaries are larger than 50K, they are larger than 40, right? So there are total 10,000 people whose salaries are larger than 50K. So if we change age to education and occupation, it will give me the results showing the education and occupation for people whose salary is larger than 50K. So we can use those results later if we want to do more research, like on how education will affect people's salaries. Yeah, that's all for the search functions, and that's my teammate to introduce the analytics function.
Okay. We have two analytics functions. The first one is get average salary. This function will find average salary for a specific type of job. For example, I will use this example in Jupyter Notebook to show you how this how it works. First, the get average salary takes salary data set as a data input, and what I want to know is the average salary of iOS developer, and finally I have the result, the average salary of iOS developer. And you can see we also have two partitions. For each partition, it will have an average result, and the reduce function will process the result of these two partitions, and finally gets the final result of the average salary of iOS developer, which is this number. Yeah, and this will help us find what kind of job has relatively large average salaries. This will be helpful for us to analyze the income data. And the second second function is get percent 50,000. This function actually finds the percent of a specific type of workers whose salary are larger than 50,000. We can use this function to see what type of worker have more money. And I will show you this example in Jupyter Notebook. This function takes income data set as data input, and what I want to know is the percent, how many percent of farming fishing workers having salary are larger than 15,000. And you can see I have the final result here. This result it comes from 5 partitions. I have these 5 partitions. Each partition have a total number of data instance, and the percentage. And the reduce function will collect all these results of different partitions, and finally produce a final result of these questions, which is this number you can see here. And for each search and analytic functions, we print out the input data and the output of the map partitions, and the input and output of the reduce function. By doing this will help the user understand the logic behind the function. They will know how we analyze analytics, or how we search data. This way will help them have a deeper understanding. And that's all about our projects.